Welcome to Summarize Science. Ever wonder how a small robot dog or a delivery drone can navigate the world on its own without being connected to a supercomputer? The big challenge is that these devices have limited battery and processing power, so any AI they use has to be incredibly efficient. This paper, EdgeNavMamba, introduces a new framework to solve exactly this problem, creating a super-efficient brain for navigation on small devices. The system, called EdgeNavMamba, has two main parts. First is an object detector, which acts as the robot's eyes to identify its goal, like finding a specific colored box. The researchers built this detector using a new and efficient AI architecture known as Mamba. Then, the location of the detected object is fed into the second part, a navigation policy that decides where the robot should move next. To make the eyes of the robot even more efficient, they used a clever technique called knowledge distillation. Think of it like a master craftsman, the big teacher model, training an apprentice, the small student model. The teacher model is large and powerful, and it teaches the much smaller student model to achieve similar results, but with a fraction of the resources. This process allows the final model to be tiny enough to run quickly on low-power devices. The navigation brain uses something called reinforcement learning. This is a trial-and-error process where the robot gets positive rewards for getting closer to its target and penalties for bumping into walls or going the wrong way. Over thousands of attempts in a simulation, it learns the best strategy to reach its goal. To test their system, the researchers train the robot agent in simulated environments, as you can see here. They use scenarios with different levels of complexity, from finding a single object to finding a specific target among several distracting ones. As the graph shows, the agent got very good at its job, achieving a 90% success rate even in the most complex scenario with 3 boxes. But here's the most exciting part, the performance on actual hardware. The student model was over 67% smaller in file size compared to the original teacher model. This table shows it has 31% fewer parameters than a competing baseline model, while maintaining a similar accuracy. When tested on small computers like the NVIDIA Jetson and Raspberry Pi 5, the efficiency gains were massive. This graph shows the student model achieved a 63% reduction in energy per inference on the Jetson Nano. Even more impressively, it delivered a 73% energy reduction on the Raspberry Pi 5. This means a battery-powered robot could potentially run its navigation AI for almost 4 times longer. So, to recap, the researchers behind EdgeNavMamba successfully combined a new Mamba-based architecture with knowledge distillation to create a super lightweight object detector. They then integrated this with a reinforcement learning agent to create an end-to-end navigation system that is both accurate and incredibly energy efficient. What does this mean for the future? This work paves the way for more capable and long-lasting autonomous devices. We could see smarter home assistants, more efficient warehouse robots, and even small exploration drones that can operate for extended periods on a single charge, all thanks to making their AI brains smaller and more powerful.